Multiplying fractions and mixed numbers. So yesterday we talked about how to be able to convert a mixed number into an improper fraction, which is something that is that's needed for today's lesson. Whenever you are doing operations with mixed numbers, when it comes to multiplying or dividing, don't ever try to do it in mixed number form. Okay? So we will start with 3 1/5 times, we'll do 2 1/4. Okay? So I want everyone to put on their thinking cap and think back to last year and even to 4th grade. What do you remember about multiplying fractions?
You have to find a common denominator.
Do you have to find a common denominator when you're multiplying?
I don't remember. Not all the time.
No, you do not. So I hear, I don't remember, not all the time, you have to, and a no. The no is correct. So when you're multiplying fractions, all you're doing is asking for the first fraction this many times. So I will move this so I can show you what I'm talking about there. If I had 1/2 4 times, that's the same thing as doing this. Because what I've got, there's 1/2 one time, 1/2 two times, 1/2 three times, 1/2 four times. So what do I have? I have 4 pieces out of how many make a whole? 2. So I have 4 pieces out of 2 making a whole, and that gives me the same thing as 2 wholes, right? So when you set it up like this, what you're doing is you're taking the numerators and you're going to go straight across. I need one numerator how many times? 4. 2 wholes, 1 time. And you'll get the same thing. Okay? So when you're multiplying, you do not need to find a common denominator. You just go straight across. So the reason that we take our mixed numbers out of the mixed number form, because it's really hard to do 3 1/5, 2 1/4 times. I mean, that would be a really hard picture to draw. So what we do is we convert the numbers. So just like we did yesterday, we're going to multiply the bottom and add the top. You're going to turn them into improper fractions.
Can we figure it out?
Yeah. So go ahead and work on those. I'll do them up here too.
Don't blur it out because I think that's 16.
It is 16.
She put 17. No.
Oh, yeah, I messed up. I'm sorry.
Because I looked up and
I'm sorry. Teachers make mistakes too. So you wind up with 2 improper fractions. You'll have 16/5 and 9/4, and you will multiply straight across. So we know our denominator is going to be 20, because 5 times 4 is 20. Now we need to do the 16 times 9. I just kind of come to the side and do the work. 144. Okay? So now you have to take your improper fraction and you have to turn it back into a mixed number. So you can reduce and then turn it in, or you can just turn it into a mixed number from here. I'm going to turn it into a mixed number from here because counting by 20s, we can do that. So 20, 40, 60, 80, 100, 20, 40. So that's 7 whole times and 4 20ths. Okay? And so now I can reduce my 4 20ths. And that one we can do pretty easily. Divide by 4. How many times is 4 going to 4? How many times is 4 going to 20?
5.
There you go.
I have a question.
Okay.
So, if you divide, let's say I divided this by 2 because I didn't divide it by 2 in my head, but I still got 1/5. Would I still get the same answer if I divided it by another number?
So you divided by 2 to get 2 over 10, and then you divide it by 2 again. That'll be fine. It's just going to take you longer to get there. Okay? All right. Let's see. Serena, will you give me a mixed number?
5 and 7.
7/8. And Victoria, will you give me a mixed number? 2 9ths. Okay, let's solve this one. Yeah, I'm going to let y'all go ahead and work it, and then we'll talk about it.
I got the answer. So, hold on.
Hang on, Brandon.
What did I not say?
Don't look up until you're ready to check your improper fractions.
I can do math. I did it. I'm big brain.
You using your big brain today? Okay, so what do we do from here?
Find the same denominator.
Do what?
And find the same denominator.
Do we need to when we're multiplying?
Oh, wait, no.
Wait, I know the bottom number.
What?
It will be 72.
72 is our denominator. And then I'm going to take the 47 and the 29, and I'm going to go ahead and multiply them out.
Can we do it too?
Yeah.
I'm fine with that. I got the 3 wrong.
Just fix it.
Yeah.
Yeah, I'm not going to be able to simplify that one in my head or find anything to simplify it with. So this one, we're just going to have to do it with division, right? So I'm going to typo it, top in, bottom out. Okay. 72 cannot go into 1.
It can't go into 13.
It can't go into 13. 136 how many times?
2.
Ooh.
No, 1.
1. bring down my 3.
3.
Mm-hmm.
Oh my god, this is so. 5 times.
You want to try 5? So I'm going to bring it to the side and try 5.
You always start with
More.
Okay. How much more, Lottie? You want to try 8?
That's gonna be too much.
Let's see.
What?
That's it. We can't go up anymore. Yes, we can. 9. Let's try 9.
Well, let's try. I'm just going to add another 72 here because if I add another one, that makes it 9, doesn't it? So we know 9's too much, so we'll do 8.
8. And that would be.
And then we're just going to subtract it out.
Wait, it would be 576.
So what do we do with that 67?
Put it up there.
Mm-hmm.
And get your 72.
Mm-hmm.
So 18 over 6. Wait, 18 and 67.
18 and 67 70 seconds. Yeah.
Seconds.
Because it's
70. You don't say 72ths
yeah,
or 72 words. You say 70 seconds. Okay? So there's nothing really too bad about today. What mistakes do you anticipate people are going to make? Simplifying. Okay. Trinity? Oh, okay. I thought you had your hand up. Mason? Simple arithmetic problems. Okay. What mistake did you just try to make a minute ago, Ayana?
Mistake?
You tried to, and I was like, no, don't do that. Before we went to 72 here,
Oh, it's a denominator.
do you need to find a common denominator?
You know, multiply.
No. It's not going to change the results, except it's going to make the math a lot messier. Don't do that. Don't create more work for yourself. When would we use something like this? Okay, so let's talk about this. Let's say I'm going to make cookies to bring them to class. Okay, my grandma's famous chocolate chip cookies. One batch of cookies.
Wait, do I answer this time?
Nope. We'll make 8 cookies. Okay? One batch will make 8 cookies. I want each of you to have 3 cookies. Right? So let's see. That's 3 for Mason, 3 for Sarah, 3 for Lottie, 3 for Savoy. So y'all figure out how many cookies I need.
Maybe 3. Are we including 39? The areas in Brooklyn, are we including them?
Nope, just who's here right now. And Miss Brittany wants some and I want some too.
No, it's not 39. It'd be 6.
But
18.
do you want some?
18.
Do y'all two want some?
Yes.
45. Wait,
18.
45 for everybody in you guys.
No, because it'd be 36.
I
Okay.
did 45.
I hear 45, I hear 36, and I hear 39. How many people are in the room?
11. 12.
Including your 2 teachers.
14. 15. 14. 14 of us. But if you
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
14 times 3.
Okay, so we have 14 people. We want
42.
3 cookies each. That's 42 cookies.
I said that, didn't I?
I said 42.
Wait, what did I say?
You said
39.
39.
Oh, I said 45.
So if I make 1 batch of cookies, I get 8 cookies. If I make 2 batches, I get 16.
Doesn't it keep going?
If I make 3, I get 24. If I make 4, I get 32. If I make 5, Now, if I can make 8 cookies with one batch and I only need 2 more, I don't need to make a whole batch.
Don't make 5 batches. Wait.
So if I have 8 cookies per batch and I only want 2 cookies,
Before.
I want 1/4 of the batch, right? Because I can divide it into 4. So now we want 1/4 to get 2 cookies. So how many batches am I going to make? 1, 2, 3, 4, 5.
And 1/4.
5 1/4 batches, right? Because I only want to make enough cookies. I don't want any extras. Now, I need to figure out how many chocolate chips I need to buy.
Oh my
Really?
Oh
Really?
my gosh.
How many chocolate chips?
We really
Okay.
want to buy a bag of chocolate chips. Throw 'em on the
It takes 2/3 of a cup.
My mom will buy this really large chocolate chip. That's all you need. That's all you need. This large bag, like if I just be.
So 2/3 of a cup per batch. Okay? So I would need to do 5 1/4
Why you can't just do
times
5?
2/3.
Oh, over there.
Okay?
I'm mad about chocolate chips.
I'm good at most fun. I'm not 21/4.
Excellent. So it'd be 21/4 times 2/3.
Which would be 12.
42/12, right? And we know 12 can go into there 3 whole times with 10 left over. And that would simplify to 3 and 5/6. So how many cups of chocolate chips do I need?
3 and 5/6.
3 and 5/6.
A lot.
Yeah, that's a lot.
So
But then when I get to the store, do you buy chocolate chips by the cupful?
No.
Do you just walk up to this big bin and you say, I need 3 and 5/6, and you start scooping it out, and then you take it to the front? It comes in bags. So then you have to use your math skills, and you have to say, okay, how much is in this bag? This bag has 18 fluid ounces of chocolate chips. Okay? Then you have to do your math skills, and you have to figure out, well, how many ounces is in a cup? And okay, so now do you see why we're teaching you this stuff? All right.
I'm just
I'm
about
never
that.
gonna do this.
So when would be a great example of when you'd use this?
Baking.
Baking. Baking is a great time to do this.
Cooking in general. I like baking.
I have a question.
Yes, sir.
Why couldn't you just throw some chocolate chips on every cookie?
Yeah, I know, right?
Because she wants every chocolate chip to be perfect. For every cookie.
Because
Well,
that's-
how about you just buy the cookies that's already made?
Yeah.
Okay. Let me show you another time when you might use this. Great example. What's coming up next week that y'all are all excited about?
Star Trek.
Oh,
Wait, never served on Star Taste.
Halloween.
Halloween. Okay. So I've been making Celie's costume. Okay. Now, she wants to be something that is not easy to find, and when you do find it, she doesn't like the way it looks. She wants Mom's special twist on it. She's going to be Mal from Descendants, okay? So, she went and she found a dress, and she wants the dress to become Mal, so I had to take the dress apart and put the dress back together and add all the extra to it. So I knew that I needed 1 1/4 yards of tulle.
You do this at home when you make a costume?
So Lottie just asked a great question. Do you really do this at home before? Yeah, I do. Because I don't want to buy more fabric than I have to at Hobby Lobby. It's expensive. And I don't want to get there and buy the fabric and get home and not have enough. So do I calculate it? Absolutely.
Can you make my Halloween costume?
So I needed 1 1/4 yards of tulle. Now, If you've ever watched Descendants, you know that Mal wears specific colors. She wears purple, green, sometimes gold, but purples, greens, and fuchsias. Okay? As you get into season 2 or episode or the second movie and the third movie, she starts going from less purple and more fuchsia.
Yes.
So Celie wanted purple, green, and fuchsia. Okay? So I had to buy this times 3. Okay? So I hand the lady the purple tool and I say I need 1 1/4 yard, and she measures it out and cuts it. Then I hand her the green and I tell her I need 1 1/4. She measures it out and she cuts it. And then I hand her the fuchsia and I say I need 1 1/4, and she measures it out and she cuts it. Okay? Now the lady's got to figure out how much to charge me. Well, all tool is $1.29 per yard.
That's not even that much.
Okay?
Times 3.
All right. So instead of figuring out, well, she's going to pay this much for purple, she's going to pay this much for green, she's going to pay this much for fuchsia, lady says, well, let's see how much she bought all together, because it's all tool, isn't it? So here we have 1 1/4 times 3. Why did I do this?
Because it needs to be a fraction and it's easier.
It needs to be a fraction, and you put it over 1. So then we're going to multiply, add, giving us 5/4. I'm going to rewrite my problem so it's nice and neat. So it would be 3 3/4. So how much did I buy? 3 3/4 yards. Okay, so now the lady wants to figure out how much I'm going to pay. 3 3/4 times $1.29. Uh-oh.
You just turn the fraction into a decimal.
Look at Sarah with her big brain on today.
I already knew that.
Okay, what is 3 3/4 as a decimal?
It would be 3.75.
Yeah. I'm getting smart, baby.
I'm gonna be a rational number for Halloween. Yes, we're your rational number ninja things. Yes.
So 63, 67, 27 plus 3 more would be 33.
I'm done, so I didn't.
You're not dumb.
Nobody in here is dumb. Everybody in here is very smart.
They just don't use their full potential.
You have to use your full potential. Excellent. So 14, 15, 18.
They're not seriously how much you weigh, Kate.
Did you really play what?
Okay. So Sarah's like, did you really pay that much?
183.
Did you really pay that?
No, because that's per yard.
No.
What mistake did I make? Lottie, what do you see?
That's per yard, and you have 1 1/4, so it's more than 1 yard.
Nope. What mistake did I make? I purposely made a mistake. I want you to find it.
You added 2 zeros. Wait.
No, you're supposed to.
not like how
No,
long
you
it
missed
was.
the last zero.
Did you have the same value like the back?
You didn't have
Is it the decimal? Because you have to move it 2 more times.
Awesome job, Kaden. Air 5. Kaden said, whoa, wait.
Good job, Hayden. I didn't notice that.
You didn't notice it.
Isn't it plus tax?
I never did that in my day. At this point.
Oh boy.
What is this 7 going to do to the 3?
Round it.
So how much did I pay in tool?
Because look, if it actually cost them, my wife would be buying it, but also.
Exactly.
Also,
Kaden
if
said,
you
wait,
look,
if it
if you
costs
look,
that much, nobody would buy it.
These are already here. This is already the cash. This is already changed. So if you have to move it 1 more time, make it the real cash.
Exactly.
I say first force the boys to be Jay and Carlos.
Okay.